writing 2 root x plus 5 px is equals to, is it a polynomial? Is it a polynomial, Ali and Alina? Is it a polynomial? No, it's not. Okay, why? Because there is a criteria. Any algebraic expression can't be a polynomial. There is a criteria to, like, if the algebraic expression is fulfilling that criteria, then only we will be saying it's a polynomial. And what's that criteria? The power of the variable. Listen to me carefully. The exponent of the variable has to be a whole number. Exponent of variable has to be a whole number. Here, what is the variable? What is the variable over here?
X.
X. And what is the exponent of that? What is the exponent of that?
Half.
What you said, Ali?
Ma'am, 1/2.
Exactly, 1/2. Is it a whole number?
No, ma'am.
Hence, it's not a polynomial. The exponent of the variable has to be a whole number. Then only we will say it's a polynomial. Okay. Here, x, root x, square root of x can be written as x to the power 1/2. See, the square root of x can be written as x to the power 1/2 in exponent form. Cube root of x can be written as x to the power 1/3. Nth root of any number 5 can be written as 5 to the power 1/n. Okay, if we understand that, then we understand that x, the exponent of x is 1/2 over here. It's not a whole number. And if it's not a whole number, then if the given expression is not a polynomial. Okay, now suppose I will write root 2x plus 5 qx is equals to, is it a polynomial?
Yes, ma'am.
Yes, it's a polynomial, because again I would repeat, the criteria is the exponent of the variable that has to be a whole number. But here, exponent of the variable, yeah, the variable is x and that's exponent is 1. Is that a whole number? Yeah, that's a whole number. So is it a polynomial? Yes, it's a polynomial. What about this root 2? Coefficient can be anything. Coefficient, constant number, these terms can be anything. We are just focusing on exponent of the variable. Exponent of the variable. If that is a whole number, then it's a polynomial. Now let's see, I'll write 1/x plus 2 hx is equals to, is it a polynomial? Is it a polynomial? Ali, Alina, is it a polynomial?
No, ma'am.
Why?
Yes, ma'am.
Yes, it's a polynomial. If no, why no? Ali, why?
Ma'am, because it is 1/x.
It is 1/, yeah. And when we will write it in the numerators part, it will come out as a x to the power -1. Yes or no? Yes or no? Do you know
Yes,
this
ma'am.
rule? Do you know there is a rule of exponent which says that a to the power -m is 1/a to the power m? That rule says that whenever you will change the place of any term, if it is already sitting in the numerator and if you are going to write it in the denominator, or maybe you are taking it from denominator to numerator the way we did now, you have to reverse the sign of the exponent. Nothing will change. This x to the power 1 from the denominator, we are allowed to write it in the numerator, but only one change will be there. The exponent will reverse its sign. If it is positive, it will become negative. If it is negative, it will become positive. When we are switching the place from numerator to denominator, or maybe from denominator to numerator, if you are changing the place of any term, its power will reverse the sign. If it is positive power, it will become negative power. If it is negative power, it will become positive power. That's what this rule of exponent says. Are you getting it? Let me give you more example. Suppose we are having 5 square. Okay. If we will write it in the denominators part, we can write it, but only the exponent will reverse its sign. If it will be 5 to the power minus 2, we can write it in the denominator, but only the exponent will reverse its sign. Then what will be there in the numerator? Nothing, 1 will be there. Getting it? That's the law of exponent. Okay. And that's what you have done so far. You have done that whenever we get 5 to the power minus 2, quickly we write it as a 1 by 5 square. But it is not limited till here. We must understand the meaning, the exact application of this rule. Are you getting it, Alina and Ali?
Yes, ma'am.
Okay, so 1 by x can be written as x to the power minus 1 plus 2. Again, the same question. Variable is having the exponent as a whole number. Yes or no? Minus 1, is it a whole number? Minus 1 is a whole number, right? Minus 1 is a whole number, right?
Yes, ma'am.
Yes. Minus 1 whole number है.
No, ma'am.
Minus 1 is an integer, Ali.
No.
Whole number starts from 0. 0 से जो counting number starts होता है, 0, 1, 2, 3, 4, 5, 6, 7, 8, all the counting number, those are whole number. Right? Minus 1 whole
Yes,
number
ma'am.
नहीं है. And hence 1 by x plus 2 polynomial नहीं है. क्योंकि the denominator's x, we will always try to bring it in the numerator's part, and then only we will decide. And once we did so, we realized that then the exponent of the variable is not a whole number, and hence it's not a polynomial. If you understood polynomial, then let's get back to polynomial function. Now in polynomial chapter, we have learned about different types of polynomial. According to the degree of the polynomial, each and every type of the polynomial was having its particular name. Linear polynomial, quadratic polynomial, cubic polynomial, quartic polynomial. Do you know these polynomials? Do you know? If I will be writing 2x plus 5, what is the degree of this polynomial?
1.
Degree means highest power of the variable. Yeah, it's called linear polynomial. Okay, the name is linear. If the degree is 2, it's called quadratic polynomial.
Quadratic.
Yeah. If the degree is 3, maybe just x cubed plus 20, or x cubed plus 20x square plus 2x plus 5. It's a cubic polynomial. Okay, so this much only you need to know. So when we are having polynomial function, the standard form of polynomial function in your book, it is written like this: f of x is equals to. Now let me help you recalling connecting the dots, connecting the concept which you already know. Let me write the expression which you will be seeing everywhere in books and everywhere. So it is given, it will be given like this: a0, then a1 x plus a2 x square plus an x to the power n. That means polynomial function कुछ ऐसा दिखता है जो कि बहुत ही confusing है. Okay, now let me give you example. Suppose px, or maybe f of x only I am writing. F of x is equals to the same: x cube 20x square, x cube 20x square plus 2x plus 5. This example we have taken for polynomial. We can call it polynomial function. See, this is how only the standard format is also given, but in reverse way. a0 सबसे पहले कांस्टेंट को लिख दिया है फंक्शन में, ठीक है, उसके बाद x वाला टर्म होगा, उसके बाद x स्क्वायर वाला टर्म होगा, ऐसे ऐसे करके इंक्रीजिंग ऑर्डर में जाएगा. यूजुअली अब तक हमने पॉलिनोमियल ऐसा कुछ देखा है कि पहले हाईएस्ट पावर होता है, फिर उससे लोअर, फिर उससे लोअर, फिर उससे लोअर. स्टैंडर्ड फॉर्मेट क्या बोलता है? स्टैंडर्ड फॉर्मेट बोलता है कि पहले कांस्टेंट होगा, उसके बाद x वाला टर्म अगर है तो वो होगा, ठीक है, उसके बाद एक्स स्क्वायर वाला टर्म होगा, उसके बाद एक्स क्यूब वाला टर्म होगा. ऐसा कुछ दिखेगा हमारा पॉलिनोमियल फंक्शन. इसको जो हमारे पास पॉलिनोमियल फंक्शन ऑलरेडी है, we can also write it like this. Let's write it. 5 we can write at first, then 2x we can write, then 20x square we can write, and then x cube we can write. Is there any difference between this one and this one? Is there any difference? Is there any difference? Is there any difference between x cube plus 20x square plus 2x plus 5, or the other one 5 plus 2x plus 20x square plus x cube? Is there any difference between this rectangular box and this rectangular box? Is there any difference? Still confused? If I will write 5 plus 4 plus 3 plus 9, or will do 9 plus 3 plus 4 plus 5. Is there any difference? Is there any difference? Will the answer get changed? Yes or no? Lena, Ali? Will the answer get changed? Reply yes or no at least. If you will change the order, will the answer be different? Yes or no?
No.
No. All are in addition. Even if it will be in subtraction, and if we will use the proper sign, then order doesn't matter. Order doesn't matter. Minus
Ma'am, I
3
meant
plus
no, it will not change.
yeah, I understood, Alina, that you understood. I am explaining to Ali now. I am not sure whether Ali understood or not. Yes, Ali? Alina got it.
Yes,
I can
ma'am,
see.
understood.
Okay. So you have to let me know. Otherwise, I will keep on just explaining this one, and we will waste the whole class for this one. Okay. So if it is clear, let me know. If it is not clear, if you are quiet, I am thinking that it's not clear. Okay, so next time whenever you will be quiet, I will keep on explaining and will be thinking that it's not clear to you. So please, again and again, if I will explain, let me know at least that it is clear. We can proceed. So the standard format of polynomial function is a0, a1x, a2x square, and then the highest power an x to the power n, whatever is there. Okay, we have also seen the polynomial in this form in previous classes. X cube, 20x square, 2x plus 5. It's a cubic polynomial, and always the arranged format was the highest power, then is smaller than that, then is smaller than that, then is smaller than that, which we can write in reverse way. So what? There is no difference between the standard format and the polynomial which we have written. The example which we have taken over here, the example which we have taken, there is no difference. The format, it's same exactly. Okay, so here and there, like the order of the terms doesn't matter. We are talking about still the same polynomial which you have learned in the class 9, then in class 10, and then there is a continuation of polynomial function. Now it is fulfilling the criteria of function. We are going to discuss the polynomial function in class 11. Okay, so polynomial functions standard format is this one. And whenever you see this standard format, please don't get confused. Here A0, A1, A2, A3, AN, these are just the numbers. These are just the numbers, the constants. Okay. Now, one example of polynomial function we can take as a, now you understand that there are so many different possibility for polynomial function. It can be cubic, it can be quadratic, it can be linear. Okay, so let's take one example. Suppose we are having a function f of x is equals to x square. Okay, this is also a polynomial function. Or maybe if we are taking f of x is equals to x cube, this is also a polynomial function. Okay, these two are example of polynomial function. If you understand polynomial, then any time you will be able to understand whether the given example is an example of polynomial function or not. Okay, here degree is 2, here degree is 3. This one we were calling cubic, here also cubic function we will be calling. It's a polynomial function having a specific name, cubic function. And this one, the here the highest power is 2, which we were calling as a quadratic. So here also we can call it quadratic function. Let's continue. Now we were discussing about the graphs. Graph of constant function, graph of identity function, graph of polynomial function I will not show you, क्योंकि polynomial के अंदर बहुत सारे टाइप्स वैरायटीज आते हैं. ठीक है, तो एक पॉलिनोमियल फंक्शन का सर्टेन ग्राफ मैं प्लॉट कर दूं और बोलूं कि हमेशा ऐसा ही ग्राफ होता है पॉलिनोमियल फंक्शन का, ऐसा नहीं है. क्योंकि पॉलिनोमियल के अंदर लीनियर भी आता है, क्वाड्रेटिक भी आता है, क्यूबिक भी आता है, डिग्री 4 भी आता है, डिग्री 5 भी आता है, सारे आते हैं. सबको इन जनरल पॉलिनोमियल बोलते हैं. ठीक है, तो जस्ट हमें समझना है कि पॉलिनोमियल फंक्शन होता क्या है. और नाउ वी विल सी these are few example of polynomial function, how exactly the graph we will be getting for this one and the graph of the other one. Better let me show you on the just a moment, let me show you on the other screen. Can you see the screen? Can you? This is how our graph will look like. How we are plotting this graph? With the help of the same table which you have learned any, like in your previous class. Make the table, take randomly any x value and find the y value with the help of the given equation and locate it on the coordinate axis, and then let's join them all to plot the graph. So this is when you will be taking y is equals to x square. When you will make the table, this is how you will be getting the graph. Okay, y is equals to x square का ग्राफ कुछ ऐसा दिखेगा. ठीक है, when we will be taking x as a 0, y will come out as a 0. Okay, when we will be taking Now see the points which I am locating over here. When we have taken x as a 1, according to the equation, y will come out as a 1 only, right? When we will be taking x as a 2, y will be coming. We are trying to just analyze the graph. Okay, we are trying to understand the graph. Graph को कैसे read करते हैं यहाँ पे समझेंगे. ठीक है? When we are taking x as a 2, y is coming out as a 4, right? According to the equation, y is equals to x square you are having. When you will be taking x as a 2, y will come out as a 4. Now when you will be taking x as a -1, then also y will be coming out as a 1. Okay? Then according to the graph, are you able to analyze कि x नेगेटिव भी ले सकते हैं, x पॉजिटिव भी ले सकते हैं, लेकिन y हमेशा पॉजिटिव ही आ रहा है. Are you able to analyze from here? Are you getting it? y तो हमेशा पॉजिटिव ही आएगा क्योंकि डाउनवर्ड साइड vertical line में upward side y is positive, downward side y is negative, and whatever graph portion we can see over here, if I will just minimize it, keep on minimizing, then also you can see downward portion on vertical line y axis, there is no part of the graph, only it's there on the upward portion. It is there on the right side where x is positive, it is there on the left side where x is negative, but on y axis if we will compare, it is just on the upward side we are having the graph. That means whatever we want we can take as a x, but y will come out as a positive number. Yes or no? And if you understood, then tell me what is the domain, what is the range. Whatever we want, we can take as a x, towards the right, towards the left. But y will come out as a upward direction, positive value only. What is the domain? What is the range? Graph को देख के बताओ domain क्या है, range क्या है. Domain is
R.
R. All real number we can take. Of course, negative number also we are allowed to take. And what is the range, Alina? Perfect. Ali?
Only positive integers.
Only positive integer. What about 0? Yes, 0 also can come.
0 and positive integers.
And this is from 0 to infinity, anything we can get,
Whole
but
number.
not the negative. From 0 to infinity, not only whole number, because you can check Alina, decimal graph के ऊपर decimal value भी आ रहा है. Can you see y value decimal
number?
Yeah, it can be rational, it can be irrational, doesn't matter. We will say that it will come from 0 to infinity. सारे रियल नंबर होंगे 0 से लेके इंफिनिटी के बीच में, बट नेगेटिव नहीं होगा आउटपुट कभी भी. Getting it? Getting it, Ali and Alina? Rational number we cannot specify. Why we cannot specify? क्योंकि x तो कुछ भी ले सकते हैं, irrational भी ले सकते हैं, x तो irrational भी ले सकते हैं. x बोल रहे हैं रियल नंबर लेंगे, रियल का मतलब क्या होता है? रियल का मतलब रैशनल भी ले सकते हैं, irrational भी ले सकते हैं. अब कोई irrational नंबर का स्क्वायर कर दोगे तो आंसर तो irrational आ सकता है कि नहीं आ सकता? Am I making sense?
Yes, ma'am.
Okay. So domain is according to the graph. According to the graph, domain is, this is how you have to read the graph. Okay. Please try to understand it from the graph itself. The domain is all real number. Anything can be taken for x, but y will always come out as a positive. That means from 0 to infinity. Let me write it. So domain is R and ranges from 0. 0 is also there. I will write the close bracket over here because when we have taken x as a 0, it came out y as a 0. So 0 point I am including over here until infinity. Infinity we always keep open interval over. Is it making sense to you? Yes or no? Ali and Alina? Got it? Shall we proceed? Any confusion so far?
No, ma'am.
Now let's see the graph of x cube. Okay. Just by looking at the graph, make it a habit to analyze domain and range. Function, even if we don't know the function, just by looking at the graph, you have to tell what is the domain, what is the range. And yes, those concepts exist. In your curriculum, in CBSE, it's not there, but in IGCSE, it's there. That just by looking at the graph, we have to say that what is the domain, what is the range, and different types of graphs will be there. And just by we will be analyzing the graph, we will be looking it very carefully, and we will try understanding the pattern, what can be X, what can be Y. So let me show you the other graph. See the graph. अब बताओ क्या है डोमेन और क्या है रेंज. ग्राफ को देख के ही पता लग रहा है कि क्या है डोमेन और क्या है रेंज. बताओ. देखो ग्राफ ऊपर भी just it's keep on going and keep on going and keep on going and keep on going till infinity. In downward direction it is just keep on going. So what is domain, what is range? Analyze it and let me know. Ali and Alina. Yes, Ali. What is the domain? What is the range? Can you see the graph? ध्यान से देखो ग्राफ को. छोड़ दो अभी जो फंक्शन है. Yes, Ali, domain is all real number. And what about the range? It's there on the upward direction also. It's there on the downward direction also. Till how long it is going? It will just keep on going and keep on going and keep on going. Okay, it is just going till what is the range? ध्यान से देखो ग्राफ को. What is the range? Exactly. Minus infinity to positive infinity, everything will be there in the output. That means the range will be all real number, or you can also say it minus infinity to positive infinity. Everything is the range. Getting it from the graph? Are you able to see? Yes or no? Alina, are you getting it? Okay. Okay, so
Yes,
these
ma'am.
are two examples of polynomial function. We have seen what is the domain, what is the range. We understood how to analyze it from the graph itself. Who will give us the graph? This, like, we won't be able to say this type of structure in the exam. So what? We know how to plot the graph, and we will be able to plot the graph as well. You can take any few numbers. You can take x as a 1, x as a -1, x as a 2, x as a -2, and you can check in rough portion how exactly the graph is going. You have to memorize the graph also over here. Okay, that cubic functions graph looks like this. This is f of x is equals to x squared. This graph looks like this. Okay, it's a parabola and it's just passing through the origin. It looks like this. Constant function graph looks like this. Okay, and identity function graph look like this. You should know each and every graph. One day just sit with pen and paper and try to make the graph of each and every function, and from then once you will draw it by yourself, it will just get registered in your mind that yeah, this is how we are getting the graph, and you should know the graph as it is. Okay, now the next function is rational function. So far everything is clear? Is it clear so far? Now let's continue with the next function, that is rational function. We are going to see what exactly is rational function. We know what is rational number, any number which is in the form of p by q, where p and q are integer and the denominator q not equals to 0. That's called rational number. Here, rational function. So, rational function will look like px by qx, where px and qx both are expression, algebraic expression, where the denominator should not be 0. Because in mathematics, if denominator is 0, that is not defined. Okay, so denominator should not be 0, and that's called rational function. बहुत सारे rational. Like, we cannot say there is a particular graph for rational function. Just like the polynomial function, polynomial, inside the polynomial, so many different types are there, different examples will be there. So what exactly is polynomial function, we have to understand, and we have taken two examples and we have seen the graph. Now we understood what is rational function, px by qx format, where px and qx are algebraic expression, denominator should not be 0. Those function is called rational function. And now we will take one of the example. Okay, so we cannot say that this is the sure and certain graph of the rational function. No, it depends upon the given function. Okay, so let's take 1 by x. 1 by x. X should not be 0 over here. Otherwise, the function will not be defined over here. A rational function example we have taken, that is 1 by x. 1 by x is one of the example of rational function. Okay, let's see how exactly the graph of 1 by x will go. You can plot the graph by yourself as well. Again, I would remind you, you can make the graph by yourself by taking any random x. Okay, by taking any random x as a 2, x as a 5, x as a, let's say, 4. By any random x value you will be taking, and you can find y value with the help of the given function, and then you can locate the coordinate, you can make the graph. But we will see the graph directly. Can you see the graph? Can you see the graph? कैसे behave कर रहा है rational function का graph? One of the example 1 by x we have taken, and how the graph exactly behaving. Can you see 1 by x? Because when you will take x as a 0, y will not be defined. That's why here at 0 we are not having any portion of the graph, because here the function will not be even defined. Okay, so 0 के पास जाके दूर भागेगा ये, ठीक है, because at 0 the function is not defined at all. You can see the graph how exactly it looks like. Now tell me, what is the domain, what is the range? X can be taken, first tell me what is the domain. X can be taken as anything but not anything but not which number which we must not take, not at all. 0.
0.
So domain is all real number minus 0, because 0 never ever we are going to take. Okay, that's the domain. And what is the range? What is the range? ध्यान से देखो, y कुछ भी हो सकता है. y का मतलब वर्टिकल एक्सिस सिर्फ देखना है, देखते रहो. वर्टिकल एक्सिस यहाँ से ऐसे ऐसे मूव कर रहा है, दैट मीन्स इंफिनिटी तक चला जाएगा. कहाँ तक जाएगा? इंफिनिटी तक जाएगा, अपवर्ड डायरेक्शन में, अप डाउनवर्ड डायरेक्शन में. देखो ग्राफ को, यहाँ से ऐसे मूव कर रहा है, कहाँ तक जाएगा? इंफिनिटी तक चला जाएगा, माइनस इंफिनिटी डाउनवर्ड डायरेक्शन में. ठीक है, तो अपवर्ड डायरेक्शन इंफिनिटी प्लस इंफिनिटी, डाउनवर्ड डायरेक्शन में भी ग्राफ वैसे ही मूव कर रहा है. It seems like it will go till minus infinity in the downward direction. Yeah, it will go. Yeah, it will go. But can you see the output will never ever be 0? You see, y will also be never ever be 0. Whatever you are going to take as a x, y will not come out as a 0. Will it come? Will it come? Have we discussed one concept in the previous class maybe, that there is a method to find the range. We can think about range like this. If we are having y is equals to 1 by x, this equation we will try writing in terms of x by making x as a subset, or maybe by isolating x, by keeping x separately on one side. If we will try doing so, x equals to 1 by 1. Now here we will start thinking, what can be the possible value of y? Just like the domain only we have to think. Forget about we are finding range. Think like a domain and think what can be the possible value of y, and tell me what conclusion you are getting from it. Y can be anything but not 0, right? Y can be anything but not 0. Yes or no? Yes or no? आ रहा है समझ में यहाँ से कि y कुछ भी हो सकता है लेकिन 0 नहीं हो सकता. कोई भी रियल नंबर ले सकते हैं लेकिन 0 नहीं. For y, if we are thinking like a domain, are you getting me, Ali and Alina?
Yes, ma'am.
So we will say all real number minus 0, or we will say that minus infinity to 0 and then 0 to infinity. मतलब सब कुछ but 0 नहीं, क्योंकि ओपन इंटरवल लिया है तो एंड पॉइंट कंसिडर नहीं होता है. ओके, This is one of the example of rational function, and we have found the domain and range of this function. Let's do the next concept. Modulus function, which is very important, very, very, very important modulus function. Modulus function is defined like this. I am writing the function. Before that, when you were in lower class, or when I was in lower class, someone told me, my teacher told me that whenever we will be having inside this modulus absolute value function, inside this sign, if there will be any number, it can be negative number, it can be positive number, it can be any number, the result will always be positive. If it is -2, then also the result will be 2 only, +2. If it is +2, the result will be +2 only. So if there is a sign of absolute value function or modulus function, it will always generate the positive result. That much we have learned in the lower class. Yes or no? Yes or no? Do you know that? Do you know that absolute value function, if we will be writing -24 is there, the result will be just 24? Do you know that? No? You have never seen this absolute value function? Yes or no? Alina and Ali. Yes or no? Have you seen anywhere this sign previously? No, right? Yes, Ali. Have you seen this?
Yes, ma'am.
Yes. Okay. So this is what you have learned so far. Now here today you will see in detail why exactly it always gives us the positive value. So basically the modulus function is defined like this. When x you will be taking larger than or equals to 0 inside the modulus function, if you will be taking x means any value you will be taking which is larger than 0 or equals to 0, the output it will give you just x. But if you will be taking a value that is smaller than 0, a negative number you will be taking inside the modulus function, it will give you the output as a -x. Now try to understand. Whenever we will be taking any number which is smaller than x, okay, inside the modulus function, if any number is there which is smaller than x, smaller than 0, okay, smaller than 0, what it will do, it will just give one more minus sign and your number. That's why every time we are getting a positive value. That's what the modulus function does. It's just like a machine. Inside the machine, if you are dropping a number which is larger than or equals to 0, outside the same x will come out. Okay, and if you are dropping inside the machine a negative number, one more minus sign it will just put in front of that and will give you, and minus will be plus. Are you understanding? Okay.
Yes, ma'am.
It is just like a grinder, a juicer grinder. You can see here there is a nozzle. If you will just drop here, if you will drop here -5, what it will do, it will give minus of -5. One more minus sign it will put and will give the result, which eventually be +5. We know that minus of -5 is a +5. If you will just drop 2 over here, it will give you 2 as it is. So if you will be dropping any number which is larger than or equals to 0, if you will drop 0 over here, it will give you 0 as a result. Okay. If you will drop any positive number, it will give you the result as it is. If you will drop a negative number over here, it will just give one more minus sign and will give you the output. And that's why we say, we have learned in the lower classes that whenever we are having the modulus function, the result will always be positive. That's why the result will always be positive, because you are dropping a negative number and it is giving one more minus sign, and hence the result is becoming positive. And how the modulus function will, the graph will look like, let me draw the graph. Yeah, the modulus function graph will look like this. This is how the graph of modulus function f of x is equals to modulus of x will look like. Whatever you will be taking, x, a positive number if you will be taking, c. Whenever you will be taking x as a positive number, the result will be positive. You can see on the graph itself. Whenever you will be taking x as a negative number here, still the output will be positive. You can see in the graph itself. Okay, that's what, like this is the graph at 0, 0. You can see when x is 0, the output is also 0. That's why both the line is touching at 0, 0 origin. Okay, this is the graph of modulus function. Now, domain and range. What is the domain? What is the range? What is the domain? What is the range? पहले domain बताओ. What is the domain? Yes, domain is all real number. We can take anything. We can take anything as x value. And what is the range? You can check. Here, positive x we can take, negative x we can take. So obviously, all real number we can take as x. And what will be the range? 0 to infinity. Exactly. Range will be 0 will be there. We can see 0 is there. Output when we input when we are taking x as a 0, y is coming out as a 0. And what is the range? Just look at the graph. It is just on the upward side. That graph, recall it. This type of graph, we were discussing the polynomial function graph. Okay, this is somehow like that only. And again, I would repeat, it is only on the upward side. Only the y-axis, upward direction, the graph is there. That means positive number we will be getting only. 0 to infinity is the range. Is it clear?
Yes, ma'am.
Now the next function, that is greatest integer function. अब फ्यूचर में क्या एक्सपेक्ट किया जाएगा कि जैसे ही हमने बोला मॉड्यूलस फंक्शन, स्टूडेंट के माइंड में ग्राफ पेस्ट हो जाए. अच्छा, मॉड्यूलस फंक्शन का ग्राफ ऐसा दिखता है, उसका डोमेन ये होता है, उसका रेंज ये होता है. These three information is very important and it must be pasted in your mind. In class 12, teachers and everybody will expect that you already know this thing. You already know the graph, you already know the domain, you already know the range, you understand the graph as well. Okay, and the function in detail also you understand. Modulus function means when x is greater than or equals to 0, the output it will give only x. When x is smaller than 0, the output it will give as a minus x. You understand already this much knowledge you are already having. Okay, and from here we will start the discussion. Now the next function which I said that greatest integer function. Greatest integer function, we represent it like this. Okay, this rectangular box. Okay, we represent our greatest integer function like this. And the meaning of this is it will always give you the result as an integer. It will always give you the result as an integer value. How it will give you the result? You can take any x value. You can take any x value. You can take an integer number, you can take a decimal number, anything you can take. But the result output will be always integer. That's what the name says, greatest integer function. It will always give the integer as an answer. Suppose you have taken 2.5 inside this box. Okay, rectangular box. Just a second. Am I audible? Am I audible? Can you hear me? So suppose you are having 2.5. As an input you have taken x as a 2.5. Output it will give you the integer which is this nearest integer, which is smaller than nearest integer. Which is smaller than or equals to the given value. The given value is 2.5. 2.5's nearest integer, which is the nearest integer to 2.5, which is smaller than 2.5 or maybe equals to 2.5. Can you tell me what is the nearest integer which is smaller than or maybe equals to? Why we are saying equals to? Because sometime inside the box you will be having just 2. So if it is already integer, take it like this. That's why equals to is there. That sometime equal whatever is there, that only will come out as a result. Can you tell me what is the integer which is smaller than 2.5? Integer. Ali and Alina. Ali and Alina. Exactly. 2.5 के पास सबसे पहला जो इंटीजर होगा, जो उससे छोटा होगा, smaller than I have written. Okay, that is 2. So 2 will be the answer. Okay, if you will be having 2.79, still the same nearest integer which is smaller than this, that means the result will be 2. If you will be having 2.99, again nearest integer which is smaller than 2.99, that is 2 only. Now if I will write minus 2.99, tell me what is the nearest integer which is smaller than minus 2.99. Exactly. Now it will be minus 3. Now it will not be minus 2. Be careful. I am saying nearest integer. 2, 3. 2.99 somewhere यहाँ होगा, but उसका place matter नहीं करता है. यहाँ पे ये matter करता है कि 2.99 से छोटा integer लेना है. अगर हमने 2 ले लिया, अगर suppose let me give you another example. We will get back to this one. Yes, Ali, you are correct. Alina, are you getting it? Suppose I have taken minus 2.1. Now, what will be the result? Can you tell me, Alina? Alina, can you tell me? Yes, Alina? नहीं, नियरेस्ट इंटीजर जो माइनस 2.1 से छोटा होगा. इंटीजर का मतलब क्या होता है? इंटीजर लाइन सबसे पहले क्लास लोअर क्लास में हमने पढ़ा था. 0, 1, 2, 3, 4 ये सब इंटीजर्स है. -2, -3, तो ये सारे जो होल नंबर्स है पॉजिटिव और नेगेटिव साइन के साथ, इसी को इंटीजर बोलते हैं. और ये जो ग्रेटेस्ट इंटीजर फंक्शन है ये ऑलवेज आउटपुट क्या देता है? इंटीजर्स देता है. सिर्फ इंटीजर्स पॉजिटिव नेगेटिव साइन के साथ इंटीजर वैल्यू आउटपुट देता है. तो अगर हमने -2.1 ले लिया तो ये क्या आउटपुट देगा? जो भी इसके पास का इंटीजर है. ओके, लेकिन -2.1 से छोटा होना चाहिए. कंडीशन ये है कि पास का भी हो और छोटा हो. -2.1 कहाँ पे लाई करेगा? इतना तो हमें समझ में आता है कि -2.1 यहाँ लाई करेगा, मे बी यहाँ लाई करेगा. एग्जैक्टली हमें नहीं पता, लेकिन ये -2 से -3 के बीच में ही लाई करेगा. तो इसका नियरेस्ट इंटीजर क्या है? -3 भी हो सकता है, -2 भी हो सकता है, कुछ भी हो सकता है. लेकिन अब ये सोचना है कि कौन सा वैल्यू ऐसा है जो छोटा है, -2.1 से छोटा है. तो अगर एनालाइज करेंगे तो हमें पता लगेगा कि -3 जो है ये छोटा है -2.1 से. -2 बड़ा है. -2 is bigger than -2.1. Do you know that -6 is bigger than -7? Do you know that, Alina? When we are comparing two negative number, then the smaller number is the bigger one. Do you know that? Do you know that? Alina, I'm asking you, when we are comparing two negative number, do you know that the whatever looks smaller, that is the bigger one?
Yes, ma'am.
So similarly, we understand that in between -3 and -2, which one is greater than? We are having which one is smaller than. Okay, nearest integer which is smaller than. So we understand that -3 is smaller. -3 is smaller than -2.1. तो यही आंसर होगा, -3 होगा आंसर. जब भी ग्रेटेस्ट इंटीजर फंक्शन के अंदर कोई भी वैल्यू होगा, अगर ये -3 है, इंटीजर है ऑलरेडी, तो रिजल्ट इंटीजर ही होगा. अगर कोई डेसिमल नंबर है तो पास का इंटीजर, लेकिन बी केयरफुल, पास का इंटीजर तो ठीक है, लेकिन स्मॉलर इंटीजर ही आंसर होगा. जैसे कि 1.5 ले लिया, अब नियरेस्ट इंटीजर विच इज स्मॉलर देन 1.5 लेना होगा. 1.5 के पास का वो इंटीजर जो कि 1.5 से छोटा हो। तो हमें इतना समझ आना चाहिए कि 1.5 तो 1 और 2 के बीच में लाई करता है। अब कौन सा आंसर होगा, 1 होगा या 2 होगा? तो here I have clearly written, read it, nearest integer which is smaller than, smaller वाला लेना है हमें। तो 1.5 से छोटा 1 है तो 1 होगा आंसर। आ रहा है समझ में? सिमिलरली अगर -1.5 ले लिया तो हमें इतना समझ आता है कि -1.5 -1 से -2 के बीच में -1.5 होता है। अब यहाँ भी आंसर जो होगा वो नियरेस्ट इंटीजर होगा, लेकिन जो भी आंसर होगा वो -1.5 से छोटा होना चाहिए, छोटा। अगर यहाँ -1 ले लिए तो ये तो बड़ा हो गया -1.5 से, ये आंसर नहीं हो सकता। आंसर होगा -2। जब भी डेसिमल नंबर हो, जब भी नेगेटिव नंबर हो, थोड़ा सा केयरफुल होके ग्रेटेस्ट इंटीजर फंक्शन का वैल्यू लिखते हैं। आ रहा है समझ में? आर यू गेटिंग इट अलीना?
Yes, ma'am.
Now let's see the graph. Wait, I think I need to take the function. Okay, I need to check here what can be taken. Let me show you on the screen by just plotting the graph. Let me show. 1, 2, 3, 4, 5. 1, 2, 3, 4. The graph will look like this. When you will be taking 1 inside the greatest integer function, the output will be 1. Okay. When you will be taking 1.1, the output will be 1. When you will be taking 1.12 or 1.15, anything, the output will be nearest integer which is smaller than 1.15, that is 1. So 1.99 still you will be taking, the output will be 1. So 1 till 1.99, till 1.99 your output will keep on coming as a 1. So from 1 I am drawing a solid circle over here which I was explaining you in the previous class. Recall it. जब हम 1 ले रहे हैं तो आउटपुट 1 आ रहा है, तो सॉलिड सर्कल. ओके, एंड देन कब तक 1 आते रहेगा 2 के पहले तक जो भी लेंगे, 2 के पहले कुछ भी ले ले, 1.99 भी ले ले, आउटपुट हमारा 1 ही आएगा. ठीक है, ऐसा होता है ग्राफ ग्रेटेस्ट इंटीजर फंक्शन का. जस्ट अ सेकंड. This is representing x and this is representing y. This is x, this is y. This is x, this is y. अब समझ में आएगा ग्राफ, ध्यान से देखो, ठीक है। 1 लिए तो आउटपुट 1 आ गया, 1.1 लिए आउटपुट 1 आ गया, 1.2 लिए आउटपुट 1 आ गया, 1.15 आउटपुट 1 आ गया, 1.99 आउटपुट 1 आ गया, ठीक है। सिमिलरली अब जब 2 लेंगे इनसाइड दिस, अब 2 लेंगे x का वैल्यू तो आउटपुट भी 2 ही आ जाएगा। तो यहाँ अब फिर से सॉलिड सर्कल ड्रॉ करना शुरू करेंगे। जब हमने 2 लिया तो आउटपुट 2 आ जाएगा और 2 के बाद 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 जो भी लेते ही जाएंगे आउटपुट 2 आते जाएगा आते जाएगा आते जाएगा। कब तक? 3 के पहले तक। अब आया समझ में इंपॉर्टेंस ये सॉलिड सर्कल और हॉलो सर्कल का। आर यू गेटिंग इट अलीना एंड अली? आर यू गेटिंग?
Yes,
yes or
ma'am.
no? सिमिलरली 3, जब 3 लेंगे तो आउटपुट 3 आ जाएगा। तो यहाँ पे सॉलिड सर्कल यहाँ बनाएंगे। जब हमने 3 को टच किया, सॉलिड सर्कल का मतलब है टच किया, हॉलो का मतलब है टच नहीं किया अभी तक 3 को, ठीक है। जब हमने 3 को टच किया, 3 पॉइंट लिया तो हमारा आउटपुट भी 3 आ गया। और कब तक 3 आते रहेगा? 4 के पहले तक। हॉलो सर्कल का मतलब है 4 को हम लोग टच नहीं कर रहे हैं, ठीक है। ऐसा कुछ ग्राफ होता है ग्रेटेस्ट इंटीजर फंक्शन का। अब अगेन सेम, व्हाट इज डोमेन, व्हाट इज रेंज? What is domain, what is range? The graph will be like this. Step, this is also called, by the way, this is also called a step function, because you can see the graph looks like steps, okay, a staircase. So this is also called a step function. So jab bhi step function ho ya greatest integer function ho, we have to think about this function only. Okay, now tell me quickly, what is the domain, what is the range? One more function is left, I will wrap it up over. What is the domain, what is the range? Domain will be anything, right? Ali, what is the domain, what is the range? Yes, Ali, unmute yourself. Any real number, exactly. Anything can be taken as a x value, but y will always come out as a, y will always come out as a, tell me quickly. Y will always come out as a integer, exactly. Y will always come out as a integer only. The name is greatest integer function. You are taking decimal number, any number, you can see here y always coming out as an integer. So domain is any real number, but the range is integer, just integer. Now the last concept is signum function. Signum function. The signum function is defined like this. Let me define the signum function. F of x when x is greater than 0, when x is equals to 0, and when x is smaller than 0. If x is greater than 0, output will always be 1. Okay. For signum function, when x is larger than 0, whatever you put, the output will be 1. When x is equals to 0, the output will be 0. When x is smaller than 0, the output will always be minus 1. So here we don't have to think about the output. Output is defined already. If you will be taking any number greater than 0 for signum function, 2, 3, 4, 5, there is no sign for signum function. Okay. we just call signum function, and this is how we define the function. That ऐसा फंक्शन, ये सिग्नम फंक्शन जो है ऐसे डिफाइन होता है, जब भी x से बड़ा कोई भी वैल्यू लेते हैं, 0 से बड़ा, that means 5, 6, 2, 3, 4, whatever you take as a x, y will always come out as a 1 only. If you will be taking x as a 0, y will come out as a 0 only. Okay, and if you will be taking x as a minus, any negative number, the result will always come out as a -1. Now, can you tell me what is the domain and what is the range, just without even looking at the graph? Let me plot the graph of the signum function. जब भी 0 से बड़ा कोई भी वैल्यू ले रहे हैं x का, 0 से बड़ा, 0 नहीं 0 से बड़ा, तो y, जैसे कि यहाँ कोई x ले लिया, यहाँ पे कोई x ले लिया, ये पर्पल डॉट देखो, ये कोई x का वैल्यू है, x1 यहाँ पे है, 2 यहाँ पे है, 3 यहाँ पे है, बट ये जो मैंने डॉट यहाँ पे रिप्रेजेंट किया है, x का कोई डेसिमल नंबर होगा वहां पे आउटपुट क्या होगा, 1. इसके बाद कोई अगर x का वैल्यू यहाँ ले लिया, सपोज ये 0.2 है, ये 0.3 है, ऐसा कुछ वैल्यूज है, अगर ये सब वैल्यूज ले रहे हैं तो आउटपुट क्या होगा, 1. Because whenever we will be taking greater than 0, the output will be 1 only. That's why the graph will look like this. Follow circle, and then in this direction the graph will move. Here also the follow circle, and then the graph will move like this. Why follow circle? Because when x is 0, then y is also 0. That's why here we need to draw a hollow circle. जब x 0 है, y axis पे कोई भी point का मतलब होता है x 0. So when x is 0, there is different output. Output is not 1. Output is not 1 when x is 0. If you want to show on the vertical axis, here y is 1, x is 0. We understand this point's coordinate is x0, y1. Okay, so when x is 0, y is not 1. That's why a hollow circle. But इसके बाद जो भी x लेंगे, y1 आते जाएगा. Similarly, when x is 0, इस पॉइंट का कोऑर्डिनेट क्या है, 0, -1. जब x 0 है तब y -1 नहीं है, इसीलिए इस यहाँ पे एक हॉलो सर्कल दिखाना होगा कि जब x 0 है तब नहीं है y -1, लेकिन उसके बाद है y -1. Are you getting it? And here we are having the x-axis. Getting it? Alina and Abdul.
Yes, ma'am.
Now, what is the domain? What is the range? Domain can be any real number. X greater than 0, equals to 0, lesser than 0, any real number. And what is the range? Range only 1, 0, -1 will keep on coming and keep on coming and keep on coming. So range is only 1, 0, -1 for signum function.